Good morning to Europe and good afternoon to Asia Pacific. Welcome to the webinar. Today's webinar will be on 2017 HSR and HSM, as well as HSS and 5-axis simulation. The webinar will be given by Amod Ankar. And before we start the webinar, Emil Sommer, the CEO, would like to just say a few words, everyone. So, Emil, you can go ahead.
Hello, good morning to our resellers and staff from Europe, and good afternoon to our resellers and staff from Asia Pacific. I just want to give you some interesting news. First of all, SolidCAM 2017 SP2 Hotfix 1 will be released either today or beginning of next week. Also, SolidCAM 2018 will be released in about 2 months, at the end of February this year. And I want to tell you another piece of interesting news. We are holding SolidCAM World 2018 on May 28, 29, 30 in Tuttlingen, Germany. Tuttlingen is the center of the medical industry in Germany, and they have a lot of SolidCAM customers, and they are about half an hour from our office in Schramberg, Germany. This will be a very interesting meeting, our SolidCAM World meeting, and I urge everybody to try to attend. Whether we are technical or sales, there will be enough interesting lectures to each of you. So look forward to meet you there and enjoy the webinar.
Okay, thank you very much, Emil. Okay, I'll switch everything over now to Amod. Amod, you are now the presenter, I believe. There we go. And you can start now.
Thank you very much, Sydney, and welcome everyone to this webinar. We're doing this webinar again. I believe this was done in October last year, and since then it's been a long time. Let's refresh ourselves with what is going on in SolidCAM 2017. Okay, so today we are going to see what's new in 2017 SolidCAM. And since the release of 2017, a lot of service packs have been released and hotfix have been released. So naturally, there are many things that are added. There are many things that are improved. So we're going to look at some of these things that got added, that got improved in 2017. And we'll also have a very short talk on what is in store for us in 2018. Okay, we're going to have a completely separate webinar on what you're going to see in 2018, but a glimpse is always exciting, and a glimpse is always better to keep you in good spirits till the webinar happens. Okay. The first major change or the major improvement that we introduced in SolidCAM 2017 was the addition of a very important tool for 3-axis customers. Okay, this has been on demand for a long time, and we finally the subject of toolpath editing is pretty critical, and there are differentiating views on whether we should have editing, whether we should not have editing. Personally, I feel that if your boundary conditions and your boundary editing conditions are powerful enough, you generally don't end up needing editing. But you could end up into certain tricky cases in which even in spite of having good bounding conditions or boundary developing conditions or boundary editing conditions, you still get unwanted toolpath in which you feel that if I just chop it off here, just chop it off here, the toolpath will look nice. I will get a much optimized cutting time. So these are some areas where you will need toolpath editing. They become very handy. Now in toolpath editing, we have got about 4 or 5 different options, out of which we have just integrated the first 3 options, which is basically editing by boundaries. You could create boundaries and chop the toolpath either outside the boundary or within the boundary. Now these boundaries can be created in any plane. Okay, there is no limitation that you need to create it only on the XY plane or YZ plane or an XZ plane. As long as you have a sketch and a plane on the sketch, you can do editing of the toolpath in the direction of the plane or normal to the plane. The toolpath will be edited. Then we have editing of the toolpath based on 2 Z levels, that I can have a complete toolpath and I can say chop all the toolpath between Z-10 and Z-15. I don't want to see the toolpath. It'll just remove all the toolpath between these 2 Z levels. And the third one is a combination of having boundaries and Z level. You could have a boundary and say from this boundary, remove between these 2 Z levels, keep between these 2 Z levels, and remove everything else. Now these are the 2 or 3 functions that we introduced in 2017. In the service packs to follow and the new versions to follow, we will add 2 more functionalities of toolpath editing, and that would be editing using holders. You could have a finishing toolpath and you would have generated with a tool, and now you would like to split the toolpath based on different out of holder length of the toolpath. Okay, so you could keep trimming the toolpath based on the outside length of the tool from the holder. And then comes the most interesting part of trimming the toolpath or editing the toolpath. Okay, this we are expecting to be in 2018, in this year. Many of you might have seen our competitors, like they have a toolpath on the screen. They just take the mouse, they drag a window and say, okay, all this toolpath in this particular window to be trimmed off. Very interesting. But unfortunately, with us in SolidWorks, we have a problem that SolidWorks does not identify the toolpath as an entity that can be recognized by SolidWorks and pass on the information to us to edit it. So we have developed something internally that allows us to do that. So you're going to see 2 nice, interesting things down the line in toolpath editing by holder and by selection. Okay, so in toolpath editing by boundaries, I generate a toolpath, I define the boundaries, and the toolpath is edited. Okay, it's as simple. I can keep the toolpath within the boundaries, or I could remove the toolpath outside the boundary. Okay, a lot of things can be done. Toolpath editing using 2 Z levels. I have a toolpath, I define the top and the bottom, and all the toolpaths outside or inside this boundary can be removed off within these 2 Z levels. Similarly, you could take a toolpath, generate a sketch in a completely different plane, and you could use that particular boundary to chop the toolpath off using toolpath editing. So it doesn't mean that you should have your sketch only on a certain plane. You could have it completely in a different zone, a different plane altogether, and the toolpath trimming will be done normal to that particular plane. And then you have the combination where you can have a boundary and 2 Z levels. So within the boundary, within the 2 Z levels, it will chop the toolpath off. So a lot of things can be done using toolpath editing. So let's just look at what toolpath editing looks like. Let me open a file. Okay. Let's take our standard HSM file. I already have a toolpath here, so I'm going to delete this toolpath, which is edited, and let me unsuppress this toolpath. Okay, so I have this toolpath out here. Now, like I said, you could edit a toolpath based on simple sketches, and the sketch could be in any plane, just any plane. To understand any plane, let's do a simple example. Okay, let's not take, last time I just took the standard XZ and YZ planes. Let's not take the standard XZ YZ plane. What I'm going to do is I'm just going to make an arbitrary plane. Okay, let's edit this part, and I'll go into plane definition, and I'm just going to take 3 points out here. Let's make an arbitrary plane. Okay, I have a plane something like that. Okay, now I'll make a sketch on this plane, and the sketch would be something like this. Perfect. Okay, so we have a very arbitrary plane and the sketch, because my user feels that if he's looking from this direction, he doesn't want a certain part of the toolpath. So I have this toolpath out here, and I click on Edit HSM and HSR toolpath. Okay, by boundary, and this boundary will be defined using this curve or the sketch. And I would like to keep the toolpath outside the boundary. Okay, you can apply boundary offset. That means you can increase the size of the boundary by providing an offset. Let's apply an offset 2, click show, and you can see that it's generated another boundary with that particular offset. Okay, so we're going to keep the toolpath outside the boundary. The editing will also allow you to change your linking. In case you've done some linking that you don't like, you can relink it based on the new links that you provide inside your editing. Okay, let's calculate this toolpath. Perfect. You can see that I chopped off this toolpath from any angle or any plane. This plane was just defined arbitrarily using 3 points, and I have the toolpath. Now, unlike most of the competitors, when you do an editing and you realize, oh, I did a mistake, I should not have done this way, I should have done the other way. In most of my competing solutions, I lose my original toolpath. I don't get it. But in SolidCAM's editing, I still have the original toolpath. I just delete my edited toolpath and I unsuppress the original one. I get my toolpath back. Okay, you can still go change any number of times you edit, your original toolpath remains as it is. Okay, this was one part. We could also remove it from this part here. So we make another sketch. Just let me edit this part. Okay, and then let's make a circle. I know it's crazy, but let's make a circle. I mean, nobody would like to trim with the circle, but just showing you what are the possibilities are. Let's edit, boundary, manual, and this is the boundary. Now this time I would like to keep the toolpath within the boundary. Okay, and everything else to be chopped out. 5 is the offset. Calculate. Okay, you can see nicely the toolpath is within the circular boundary. Now, these were gimmicks just to show you that editing is possible in any plane and editing is possible in any toolpath of HSM and HSR. Where can I actually apply, or where are the areas where this could be of importance to us? To understand that, let's look at another part. Okay. So I have this part from my customer. Okay. It's a forged part, forged die rather. And this happens many times. For example, when you're trying to do a linear toolpath using slope angle, you sometimes end up getting this kind of problematic toolpath. Now, this is not a problem with the software. This is basically the angles that you have defined is making the tool go into these areas. But this is very bad because it could really ruin up your part. Now, in our old SolidCAM without editing, this is actually very difficult to remove or to avoid. In such cases, toolpath editing becomes very handy. For example, I just take this as my created the sketch here. So I have two sketches here. I just take the sketches, and what I do is I go into editing and I'll say chop off all the toolpath that is within this boundaries. Okay, I have two boundaries, so I'm going to chop the toolpath out within two boundaries. And how it looks like, excuse me, how the toolpath looks like after editing is like this. All those areas are gone. All those problematic areas are gone. And I have a very nice toolpath that is still remaining. And this could save you in real machining time, in real world on the machine. It could save anywhere between 10 to 15%. So even if you have created a toolpath which doesn't look optimized, you can actually use toolpath editing to optimize a toolpath, remove unwanted areas, and only keep those areas where you think the tool should run. All the other areas, you just chop the toolpath out. I just thought while I was just presenting this webinar, where could be the other areas where you could use a toolpath? In many cases, for example, you have areas where you would like to keep a secondary offset, but currently our HSM doesn't allow it to keep a secondary offset. So you could generate a complete toolpath, and the areas where you think you need a secondary offset, you just mark a contour and chop the toolpath out, and using the same contour you generate another toolpath with the secondary offset. It's very practical solution to the secondary offset issues encountered during finishing operations. Although we don't have a direct solution at the moment, you could use editing as a go-to or a solution that could bypass this issue and give you a toolpath or two different toolpaths with two different offsets. Now, editing has endless possibilities. I know many of you will be thinking, okay, I can use it here, I can use it there. So we have given you a tool, and it's up to you how you would like to use this tool to create optimum toolpaths after editing and removing those unwanted areas. Okay, let's get back again to our slide. Okay. SolidCAM also allows you now in HSM to define fixtures. Okay, you could have clamps, you could have fixtures. You can use these fixtures to try and avoid the fixtures, especially if you're using, let's say, clamps like this. You can put those clamps as 3D models, and you could then define these clamps as fixtures, and SolidCAM, while doing the linking, will trim off those areas and avoid colliding or getting into a collision with these fixtures. Now, this is something that's already there. What is coming now in 2018 would be additional functionality wherein you could create an offset of these fixtures. You would like to be safe because you don't know, or your customer doesn't know how your operator is going to fix these clamps. Probably there could be some error of plus minus 2-3 millimeters. So you would want, or your customer wants to play safe. So he will then click this as a fixture, and you will get a place to put the offset value, and the entire 3D model will then be offsetted to give you a safe envelope for the tool to travel. Now that brings us to another very important highlight that's going to be in 2018, and this is going to be very, very useful for people who are going to be in sheet metal industry, or who are going to be working in the sheet metal industry. Okay, there is a question from Shimshon. I'm going to take questions in between, so you can please keep asking me. Shimshon asked us that, are there any rules for the linking to the edited toolpath? Well, actually, there are no rules. You can keep the linking as it is. Generally, that is a rule that you generally don't change the links, but we allow you to change the links while the editing is happening. So if you have created a client toolpath, you could change it to bidirectional, or you could change it to conventional when you're creating the edited toolpath. But generally, it's not suggested to touch your links when you're doing editing. You would like to keep the same linking what is there to your original toolpath. Okay, coming back to the offset of these fixtures, we are going to come up with some very interesting option in 2018, which will allow you to create stock by offsetting the entire model, like casting. Okay, a very old request from many of you people. It was on our top priority, and we hope to see it in the first release of 2018. So we're going to use this functionality to create another very important functionality for us, and that is to define the stock by casting or offsetting the entire model to a certain value. Okay. Another very important thing we've done, and in fact, this looks pretty small, but it can really save a lot of time and a lot of mouse clicks, and that is to customize your ribbon in HSM. Let's just look at how we customize it. Okay, so I have this ribbon out here, and currently the ribbon is empty. So all I do is just right click on it and go into the customize command manager, and under the commands I click on SolidCAM 3D HSM. So I've got all the toolpaths out here. Okay, for example, the first one is constant Z. So I can drag out and keep it on the ribbon those functions or those toolpaths that I'm going to use consistently, I'm going to use commonly, or very common ones. For example, I know that constant Z is something that I use it, so I drag constant Z out and keep it on the ribbon. I also know that I need to define combine constant Z with linear machining, so I'm going to drag that and put it out. What else do I need? I need 3D constant step over, and I put it back here. And then maybe this one, and then I realize, oh, I don't use this much. Combine constant Z with constant step over, so I bring it and put it back here. It disappears from the window. Now, what this customization of ribbon will do is, if I had to create a constant Z machining in our regular way, I had to right click on operations or the operation here, add milling, 3D HSM, and then constant Z machining. So about 3 or 4 mouse clicks. That completely is bypassed by just selecting constant Z machining here, and I start immediately the constant Z machining. So we are now allowing you to customize your entire ribbon bar, keep those operations which are frequently used, and you could save a lot of time in mouse clicks. It also causes a lot of frustration when you have to have mouse clicks, so many mouse clicks to come to a particular function. Right. Back again to our PowerPoint. A next important feature we released in 2017 was enabling of detection of flat areas. Now what it basically does is, if you have got a lot of flat areas and these flat areas are coming in between the two depth of cuts, SolidCAM will ignore those flat areas if the detect flat areas levels are disabled, and it will keep more stock than what has been asked by the user to be kept on these areas. But by enabling it, it will create an additional pass, or it will try to move another level close to that particular layer, the flat layer, and remove that excess material. So let's look at one quick file. So let me open detect flat areas. Okay, I'll also show you a part where probably it's going to be of use. Okay, so I have this part here. Go to the side view, and let's edit this operation. And in the passes, I'm switching this off. So what I see in the toolpath, for example, you can see that if I change the depth of cut, let's change the depth of cut. Let's make it 30. Okay, so if I now introduce, or if I add detect flat areas here, okay, and calculate, I will get a toolpath that's very similar to this. It will add additional passes on these flat areas. Now the detect flat areas is available in roughing. It's also available in constant Z. Sorry, not HSR. Let me add. Do I have it here? Yes, I have constant Z machining. So the detect flat areas is also available in constant Z. So it's added to contour roughing, and it's also added to constant Z machining. These are the two places where you will see that this particular option is available. Okay, let's move back again, forward. Now, before I jump into 2017, now this was not planned, but I would like to break this in this particular session. Let me open a file. Okay. So this new option that's been added, and you could see that in SolidCAM 2017 SP3, one of the releases. This particular option is added in HSM. Again, a long-standing request from many of our users, and I believe many of you will be very happy. We have introduced a new function in HSM, and that's called as a contour rest machining. Okay, I did not want to put this in the slide. I just wanted to break it as a surprise to everyone. Contour rest machining is a new rest machining function. So you're going to ask me, what is the difference between rest machining and contour rest machining? Contour rest machining is nothing but the same rest machining minus the limitation of the type of tools that could be used. Okay, so in contour rest machining, for example, let's assume that I have this linear toolpath that I've done with 16 ball nose. I can now take contour rest machining and define my earlier tool as a ball nose and my current tool as a bull nose. Okay, so you can probably have any combination. You could have your previous tool as a bull nose and the next one as ball nose, or your previous tool could be a ball nose, your next tool could be a flattened mill, or it could be a bull nose and a flattened mill. So we have removed all the limitation in terms of the kind of tool and type of tool that is needed in rest machining. A big major step forward for us in 3-axis machining. So if I show you the simulation of this, okay, so this is my previous stock, and I have material remaining here because I used a ball nose. Okay, and now I'm going to use a bull nose to precisely machine those areas where material is remaining. So let's go slow. Let's run it. You can see that it's precisely going into those areas where material was remaining. no longer any limitation in terms of tools. You could provide bull nose, you could provide flattened mill, you could provide ball nose, you could have any combination. Okay, so this particular function will be released again in one of the SPs of 2017. Very important breakthrough for us in 3D machining. Okay, now while we are at 3D machining, I also would like to tell you in a few seconds of our future that holds us in 2018. A very exciting future for us in 3-axis machining for SolidCAM. You will see that come 2018, we are going to be releasing a very nice, beautiful, and extremely fast calculation engine for 3-axis. The whole goal here is to speed up calculations on large parts. We're talking a few meters in length, few meters in width, and approximately, let's say, a meter in depth. Parts like these, where the calculation time for us was an issue, we are sorting out that with an exciting new engine, where the toolpath calculation is going to be faster than the fastest available in the industry today. Okay, I don't want to take names on which is the fastest, but whichever is the fastest, we are going to be faster than that in terms of calculation. Right, let's go back again to my presentation. And let's move into Sim 5X and HSS. Let's see what are the new things that are there. We introduced something called as an exact step over. Okay, exact step over basically is a small engine that gets integrated inside our existing morph between two curves functionality that allows you to calculate precise step over even on steep areas. Okay, so let's look at a file. Let's take a file. Let's take this. So what we had now here in our existing solution was that if I kept the step over calculation, or what step over was 1, and if I calculate, this was the result what we used to get. Okay, we used to get, let's switch off the lines. This is what we used to get. The step over was pretty close to the area where the curve is being picked up. Now what used to happen was, when these two curves are picked, curve contour 2 and contour 3, which is nothing but this curve and this curve, internally SolidCAM will create a surface. It will map the toolpath on the surface, and then it will bring this toolpath and take it and put it on these surfaces. Now if the shortest distance between these two curves is smaller than the entire surfaces that are need to be machined, then you will see this problem that the step over becomes really large on the furthest point, and as it comes back again, it starts getting closer to the step over that you defined. In order to overcome this problem, we added another function here inside the step over calculation. Instead of making it approximate, which is what we currently use, we have exact. So if I use exact, this is how my step over distribution now looks like. It's much more clean, precise, 1 millimeter all throughout the surface. Now this is a very simple function. You would be asking, where do we use it actually? Where can we use it? So last time I could not show you a part, but this time I have a part which did create a lot of issues for us. So let me open the part. Now please. So I have a group of surface that needs to be machined. I mean, if you look at the surfaces, they don't look really nice. Okay, so you have these surfaces here which need to be machined, and we are going to use morph between two curves. So I've got the curve on top and I have got the curve at the bottom, and then the tool axis is being controlled by this curve here. Okay, so what is the result we get? We get this result. I'm sure many of you would have had results similar to this, some crazy kind of things happening in between, especially when there are large surfaces and immediately they shorten up to get into a smaller area. Okay, so this particular problem just could not be solved by any other means other than selecting, instead of approximate calculation of the step over, if I create an exact step over and just calculate this. Okay, just by selecting exact, I solved the problem. Okay, a major issue for us, especially when we were at a customer, it was getting very difficult. So now, using exact step over, I have sorted out that issue. So you can look at issues where you have, especially in morph between two curves, you get some strange looking tool path. The step over changes some at some places. In such cases, you use the exact step over method. Okay, let's go to the next one, and this is another interesting function that we introduced in 2017, and that is the common direction. What is a common direction? A common direction is that particular tool axis that the software finds out, which is a single direction through which the entire part or the entire surface could be machined. Okay, otherwise what you would need is a 5-axis toolpath. Now, in order to avoid a full 5-axis toolpath, what the software does is it finds out that one position through which the tool could be positioned, and that entire area could be just done using a simple 3-axis machining. Okay, so let's again look at another file. Sorry. Let's open. Common direction. Right, so we have this surface here, and I want to machine this surface in 5-axis. We have got two undercut areas through which the tool should avoid the gouge, basically by tilting. Okay, there it is. As it reaches the end, it's avoiding itself using the gouge check principle. But here I'm creating a 5-axis toolpath using a function in SolidCAM 2017 called as common direction, or maintain common tool axis. We don't call it common direction anymore. We changed it to maintain common tool axis. What the software has done now is, instead of creating a 5-axis toolpath, it has found out the best possible position that it could use as a single tool axis and machine this entire part. So now you can see that the software or SolidCAM will not create any 5-axis motions, but it will simply use a regular 3-axis function, which is automatically determined or calculated by SolidCAM, that one single common axis through which the entire part will be machined, or entire surface will be machined. You can see that we are not changing any axis. It's fixed. It's like a very automatic 3+2 machining. It's found the best possible axis, locked those axes, and now it's just doing simple 3-axis machining. Okay, so it's very important. Now, what are the ingredients that you need to define common direction? Just by selecting your drive surface and you expect it to find a common direction is not possible. You need to also specify what are your check surfaces, because it needs to avoid those areas. So it needs to find a direction in such a way that you won't need any kind of gouge checks for those particular 2 or 3 check surfaces. So the ingredients are the drive surface, and the check surface. Of course, it also needs the tilting strategy that you used. Defining these and selecting the maintain common direction allows it to find the best possible position to machine the part in simple 3-axis. Okay. We are now supporting barrel tools, which are basically circle end mills. We call them barrel, but actually if you go to any manufacturer of these tools, they are circle tools. Now in Sim 5-axis, we are now supporting two types: the barrel, the bullnose, which is the corner radius, and the circle end mill. Now there's a third type which people have been asking us, which is the taper type, and that's actually supposed to be a more common kind of a circle end mill, which is also called as a taper circle end mill, or the taper form. We would start supporting it starting in 2018. Okay, we already have the structure and the framework. We have to just implement it, and that'll happen somewhere down the line. This year we'll have the taper circle end mill. Now the advantage of using these kind of tools is that we use the side flank of this tool, which has got a very high radius. Okay, we have a radius like 100 millimeters or 125 millimeters, that kind of a radius. When you have such high radius on the flanks, and when you're using this flank to cut a part, you can actually take a much bigger downstep or side step and generate the same scallop that you would do by using a simple ball nose. For that, let's look at a file here. Let's open barrel tool, circle end mills. Okay, let's open this. I want to open this file because I've created a sketch where I can explain you the principle of scallop on how it works with the barrel tool. Let's go to the top view, not this view, sorry. Okay, anyway. Okay, so here I have got my ball nose. Okay, if I measure this, this is diameter 16, so I take a diameter 16. Now in order for me to get a scallop, okay, if I measure this, this is my scallop height. In order for me, sorry, to get the scallop height of about 5 or 10 microns, I need a step over of at least 0.5 millimeter. Okay, so that's the step over that I need between by using a ball nose. Okay, so I need a step over of about 0.5 millimeters in order to achieve a scallop of about 5 to 10 microns. That's because of the diameter of the tool. Now the same principle when I use it for the circle type end mills, because of the large radius, to achieve the same 5 to 10 micron scallop, I can take bigger step over, almost 3 times than what I would take with my ball nose. So if you look at the tool path, if I look at my regular ball nose tool, this is the tool path that I would need to generate a scallop of anywhere between 5 to 10 microns. Okay, whereas if I take my oval form tool, this would be the tool path size that I would need, or the step over that I would need to generate the same scallop. It's like 3 times. That means if I'm going to cut a part in 60 minutes using ball nose, I would cut the same part using a oval form tool by at 1/3, like in 20 minutes I would have the part out. Okay, so that means that I could machine a part much faster using these tools. So if you look at the contact of these tools, okay, let's reduce it, and let's go ahead, let's go on the other side so I can show you the flank touching. Okay, here it is. You can look at what area is in contact with the part. This big flank having a radius of 90 millimeter or 100 millimeter is in contact. That's the cutting area and not the stip. Because the moment the stip comes into play, our side step drops dramatically. Because of this large flank radius, I can give a much bigger downstep, yet achieve the same kind of finish that I would achieve using a ball nose with a much smaller step down. So very important breakthrough for us in SolidCAM. We're going to have this. This feature is already available, and I believe our friends in Slovenia have already tested this. I have the videos. Maybe they can share the videos with Sydney, and Sydney can send the videos to everyone, or at least a link to everyone, and you could have a look at how the cutting happens. Okay, great. Let's move ahead. In multi-blade machining, we now support end mill and bullnose tools for roughing. Again, this was a much asked for feature by many of our users, asking us to support bullnose and flattened mills for roughing in multi-blade. We are now supporting this functionality in roughing. We are also supporting lollipop cutters for finishing. Okay, so another very important aspect for us in multi-blade. Port machining, we now support 4-axis. We can give you a 4-axis output rather than a 5-axis output, where you could want to machine a simple tube, but your customer doesn't have a 5-axis machine but just has a 4-axis machine. You could then put that simple tube on a 4-axis machine, use the port functionality, and generate an output for those 4-axis machines. Again, completely out of this context. I recently was trying to machine a shrouded impeller, an impeller that's closed from both sides. Generally, impellers are open one side; it's much easier to enter. So I was trying to machine a shrouded impeller. I'm not sure if any of our competition has directly the function, but I found reasonable success machining a shrouded impeller using a port machining functionality. The toolpath came out pretty good. Of course, we have yet to run this on the machine, but at least the quality of toolpath and the input that was needed to be provided for generating toolpath was very less. And the kind of quality that we got at the end, it looks much better than our regular 5-axis. And it was much faster, and I don't have to worry about the corners crisscrossing and all. It looks very nice. Okay, so this is an idea that I'm putting forward to our development team to see if we can move this functionality also to support shrouded impeller. Multi-axis roughing, we now support stock that you can define locally. Many a times when you are using multi-axis roughing, you will find that it starts calculating the stock, the previous stock, and then goes into all those areas where you think that it should not have gone. Then it becomes very difficult to control it. To avoid all those things, we can now define local stocks. That means stock only for that operation. And this could be defined by definition of simple surfaces. Okay, so let's look at another file. Let's open Multi-axis roughing, not here. So what I have done in this part is I have just used or defined a surface. Okay, I just used this surface and all the side surface as a local stock for multi-axis roughing. The stock may not exactly look like that, but for calculation of the toolpath, I've used only these surfaces to define the local stock, and the toolpath that I get is beautiful. Okay, just works exactly in that area. It doesn't jump and go into other areas where it finds a little bit of scallop remaining and starts machining that. So now I can be very precise with my area by doing a simple local stock only for that particular operation and start generating the toolpath. You don't need to again keep updating and then removing the areas where it doesn't, you think it should not go. All those things are past. You define simple local stock and only for that operation, and it generates a toolpath based on that local stock definition. Okay. Stock definition in multi-axis roughing can also be done using a 2D boundary. Okay, so if you don't have a surface, then you could just define a 2D boundary. But then, if your part is twisted like that, then it becomes very difficult for the 2D boundary to handle it. In such cases, you can revert to the local stock definition using surfaces. In the convert HSM to Sim 5 axis, we have added an option to maintain tilt, wherein the tool used to move from one point to the other point, and it used to change the tilt dramatically in that very small area. You could see immediately the table tilting to maintain tilt in that very small 5 to 10 millimeter area. Now, by selecting the maintain tilt option, the software will maintain the same tilt until it crosses over and then gradually will shift to the new tilt. This avoids great dancing of the axis, especially if you're using a table or a head. You can see the head immediately trying to change its direction. Okay, a very nice function, looks very small but has quite a value on the machine. Right, we also introduced a completely new toolpath function called as screw machining. This particular function enables you to machine extruders or any kind of screw or any kind of parts that have the spiral kind of surfaces attached to it. Now, it is very difficult for us, if such a part is given to us, to generate a toolpath, and that too roughing, because finishing you could somehow manage to create the toolpath. You might have much issues. But when it comes to roughing out these parts, it really is a pain. You have to create a lot of dummy surfaces, create the toolpath, stop the tool from going into some areas by creating more dummy surfaces. So the process is really time consuming. Now that is for simple. For real complex parts, people just lift up their hands and say, sorry, this is not going to happen. And then they revert back to 3-axis with positional. Okay. However, with a new functionality that we have now in SolidCAM 2017, you could machine parts that are simple as well as complex. Okay. So I just take the simple extruder. Okay, so this is my part. I go into add operation here, and I've got screw machining. So what I have in screw machining, it simply looks like a 3-axis toolpath. I select what geometry I would like to cut, what should be the offset, what should be the machining area. I define the machining area by 2 methods: the length of the part as well as the angular boundary. Okay, so I define the machining area. I pick the tool, exactly like 3-axis. I pick the tool. The clearance is automatic. Toolpath parameters, I put in the depth of cut, I put in the side step, I ask it whether you want to do zigzag or one way. If there is stock definition, I can give a stock definition, or it can automatically take a bounding cylinder for that particular part. Tool axis control, 4-axis, just define what is your rotary axis. Once this is done and you hit calculate, you get this toolpath. Straightforward. This particular part took about 3 to 4 minutes to calculate, but then you don't have to do anything. You just select the part, put in these parameters, and hit the calculate button, and you have the toolpath, almost like a 3-axis function. Once you have done this part, roughing, you can also go and do the finishing. Simply again select the part, define the tool, define your depth of cut, and your finishing is done. Okay, very important functionality for people who are in, let's say, the printing industry, plastic extruders, even some in oil and gas. So it's very important function. Now this was simple, and people could think, oh, I have got a better way of doing it. I'll do this. I'll create a surface. I'll create a tool path and then push it inside, and I could have a very nice tool path much faster than this and the way I want it. All that is fine unless you will see this part here. Let's take a complex extruder. Okay, I have this part. Now this also looks pretty much simple, only the fact is that length, it's about 1.8 meters. But wait until I zoom into these areas where you have these cutouts. Okay, these cutouts here and this one out here. Roughing this is a programmer's nightmare. Okay, it's really a nightmare to do the roughing. Again, what we did, simply selected the part, selected the stock, the tool, depth of cut, side step, and rotation direction, and I get the tool path. This part took about 15 minutes to calculate, but then 15 minutes, I would say, for such parts, compared with manual way of working, which would have taken a day at least, 15 minutes is lightning fast. Okay, it's very fast. You don't have to worry, it's machining every feature in it. Okay, and once that is done, again apply and create finishing tool paths. Look at that. Entry, exit. It's cutting into every feature that you wanted to machine. Okay, so it's doing a very neat job of machining the entire part just by a few clicks. Okay, very important function that could save several hours of programming time and can generate really optimum tool paths for roughing and finishing of these kind of parts. Okay, move ahead. So that was roughing and the finishing. All right, so I'm going to come to the end of our webinar on HSS, HSM, 5XResellers. I have tried to cover everything that was there in the software. I've also given you some exciting news of what is coming in the future and what will happen to our to the user requests. I also showed you some new functions that have already been integrated inside SolidCAM and which you will see in the next service packs and the future in 2018. We will have a separate webinar on this exciting new engine that is going to be integrated in SolidCAM, that's being developed in SolidCAM for 2018. We'll have that webinar very shortly where I'll show you all the features and the best part, the calculation time. Thank you very much for patiently listening. If there are questions, please ask the questions now. I believe there's already a question. Thank you very much.
Okay, Amod, thank you for the great job that you've done on this webinar. Extremely informative. Just for everyone's information, this webinar again has been recorded, and you'll be able to see it later on the website under the resellers area for the webinars. Okay, that is basically it for now. Everyone have a great weekend, and then we'll see you at our next webinar. Take care.